Moving on to question 4 now, we have a question with parametric equations and a little bit of trigonometry. So we've been given the curve C1, which has these parametric equations, and we also have the circle C2 with this equation, x squared plus y squared is equal to 66. And it cuts at 4 distinct points, so you've got one here, one here, one here, and finally one here. And we're given that one of the points, S, so this one here with a little black dot, lies in the 4th quadrant. And we have to find the Cartesian coordinates of S. So, this is actually, I actually quite like this question, it's quite an interesting question. And we're just going to take it slow, take it step by step, and let's break it down. So we know x is equal to 10 cos t, and y is equal to 4 root 2 sin t. Now if these two curves are, well, parametric equation that has a curve and this is a circle here, if these two intersect at 4 points, what we can say is that these coordinates here, x and y, must be able to be substituted into here if they intersect. So let's substitute them in. So x squared, so 10 cos t squared, so let's do this. 10 cos t squared plus y squared, so plus 4 root 2 sin t squared, so plus 4 root 2 sin t squared. So that's all squared. Well, that's equal to 66, right? So we've just subbed x and y into C2 here, that's the curve, sorry, the circle here. So now we just need to expand both of these and see what we'd get. So 10 cos t all squared, so that's going to be 100 cos squared t. Cos squared t. And if we expand this 4 root 2 here, well, 4 times 4 is 16 times, so root 2 times root 2 is 2, so 16 times 2 gives me 32. So we have plus 32 sine squared t. And this is equal to 66. Now some people might spot it straight away here, but we've got to do a bit of manipulation. And look at what we've got. So we've got 100 lots of cos squared t, and we have 32 lots of sine squared t. So what I'm going to change is this sine squared because the coefficient, this 32, is smaller than the 100. So it'll make my manipulation a little bit easier. So this will stay the same. This is 100 cos squared t. And then, what can I change here? So we know sine squared plus cos squared is equal to 1, or sine squared x plus cos squared x is equal to 1. So if we substitute in, what we have here is plus 32 lots of 1 minus cos squared x. So 1 minus cos squared x. Sorry, t. Cos squared t. This is equal to 66. So if you simplify it at this next stage now, I want to take the 32 across already. So what I've got is 100 cos squared plus, sorry, I'll take the 32 across, that'll give you plus 32, I'm going to subtract it off already, and I have minus 32 cos squared t. And that's going to be equal to 34. So 66 minus 32 gives us 34. So nearly there, let's keep simplifying. 100 minus 32, so that's going to give me 68. So we have 68 cos squared t. Cos squared t is going to be equal to 34. So we just need to keep solving here. So therefore, cos squared t. So at this point here, it's just pretty standard. We'll just keep simplifying and solving. That's going to be equal to 34 divided by 68, so that's a half. So we have cos squared t is equal to a half. So how do we solve this? Well, we need to take the square root, right? So if we take the square root, that's going to give us cos t. Cos t is equal to the square root, or plus or minus of the square root of a half. So what I can actually do is write that as 1 over root 2, because obviously the square root of 1 is just 1. So the square root of 1 over the square root of 2, like so. So it's the plus or minus, don't forget, so we're taking the square root. So now we have plus or minus 1 over root 2. So what I'm just going to draw here just to help with this point here now is a cast diagram. So I don't really, they're not the best, but just for this question it's going to help just a little bit. So remember the quadrant, so this is my C quadrant, A, S and T. So that's my cast diagram. And we're in this fourth quadrant here. So remember, cos is going to be positive, but sine will be negative. So I need the positive cos value here. So if you take the inverse here now, so cos inverse of 1 over root 2, what that's going to give you, therefore, is that t is going to be pi over 4. Make sure you're in radians for this, because we're working in radians, t is between 0 and 2 pi, so pi over 4. So now all we need to do is substitute this back in to our x and our y, and we can obtain the correct answer. So therefore, x is going to be equal to 10 lots of cos pi over 4. So that, what that's actually going to be is x is equal to, write down fully, 10 cos pi over 4, which is going to be equal to 10 lots of 1 over root 2. That's 10 times 1 over root 2, which is going to give you 10 over root 2, which if we rationalise, that's going to be 10 lots of root 2 divided by 2, giving us 5 root 2. So that's 5 root 2. And then finally for the y coordinate, if I do it over here, so therefore for the y coordinate, so just be very careful for the y one. So this is going to be 4 root 2 sine t. So that's sine pi over 4. But remember, sine will be negative in this quadrant, the fourth quadrant. Sine is negative, cos will be positive. So this is 4 root 2 times minus 1 divided by root 2. So that root 2 cancels with that root 2, so it's 4 times minus 1, giving us y is minus 4. So our coordinates are going to be 5 root 2 and minus 4. And they seem pretty sensible, so have a look at where we're roughly at. So this is 5 root 2 along and minus 4 down. If I clearly got a positive y value here, something would have gone wrong because we're below the x-axis. So that's a nice little check just to give you a rough idea. So quite a nice question, I do like that question, and that's question 4 complete for 6 marks.